Hey everyone! Welcome back to ZoomInData. And this is episode 20 of our KQL Concepts Deep Dive series. Today we are exploring percentile and ranking functions, the philosophy behind exact versus approximate calculations, and when to choose each. We are keeping everything pure concepts and interview focused. If you missed episode 19 on hyperlog and probabilistic counting, it's a great foundation for today's topic. Let's get started. Here is our roadmap for today. Percentile functions compute the value at a given rank, like P50 median or P95 latency. Exact percentile requires sorting or full data scan, very expensive. Approximate percentile uses structures like tdigest or other sketches, fast and low memory. Ranking functions like top, bottom, row_number can also be exact or approximated in spirit. The core trade-off is precision versus performance at scale. Understanding this helps you choose the right function for monitoring versus deep analytics. Let's dive in. Let's start with exact percentile. The percentile function with exact method sorts all values within each group. It guarantees 100% accurate result for the requested percentile, no error. But the cost is high. N log n, time due to sorting, and linear memory to hold the entire dataset. It scales very poorly with row count. Large groups can cause memory pressure or timeouts. Use exact percentile when groups are small or when compliance, reporting, or financial use cases demand perfect accuracy. Precision is non-negotiable here. Now the approximate side. Approximately_percentile uses tdigest or similar sketch-based methods. Error is typically under 1% with very low memory, just a few kilobytes per group. It's streaming friendly, updates incrementally as data arrives, no need for full sort or holding all values. Speed scales near linearly with row count, memory stays near constant regardless of data size. This makes it ideal for high cardinality percentiles like P99 latency across thousands of servers or daily user session durations. The philosophy: when you're monitoring trends at scale and 1% error is acceptable, approximate wins big on performance without meaningful loss in insight. Check out this side by side. It captures the exact versus approximate percentile trade-off perfectly. On the left is exact percentile, full sort icon, tall memory bar, and a slow turtle crawling along. It reads and sorts every single value in the group, 100% accurate P95 or P99, but it burns CPU, eats memory, and crawls on big data. On the right is approximate percentile, tdigest sketch icon, tiny memory bar, and a lightning bolt for speed. It builds a compact sketch incrementally, just kilobytes, and gives you a result with approximately 1% error in a fraction of the time, even on billions of rows. The middle divider says precision versus scale, with the balance scale tipping hard towards speed and scale on the right. The philosophy is clear. When you're monitoring live systems and need fast, reliable percentiles for alerting or dashboards, approximate wins. You trade a tiny bit of precision for massive performance gains. Use exact only when every decimal point is legally or financially critical. Choose smart, and your queries stay fast without losing meaningful insight. Ranking functions follow similar logic. Top and bottom use exact sorting. They return the true top or bottom n values, but they're limited by memory and time on large groups. Row_number requires a full sort per partition. Exact ordering, but very expensive on big data. Unlike some systems, KQL doesn't have a built-in approximate top-n function. For large datasets, the practical approach is to pre-filter aggressively or use approximate percentile first to identify thresholds, then apply exact top-n on the reduced set. Exact ranking is great on small sets. At scale, you need to lean on approximation upstream to make it feasible. Here are the key trade-offs and decision rules. Exact percentile and ranking give perfect accuracy but come with high CPU and memory cost, only viable on small data. Approximate gives about 1% error but uses tiny memory and stays fast even on billions of rows, perfect for production monitoring. Use exact for billing, compliance, or small group deep analytics where every decimal matters. Use approximate for P95, P99 latency, error rates, session durations in dashboards and alerting. Trends and outliers matter more than the exact digit. Smart hybrid pattern. Run approximate first to find rough thresholds, then apply exact on the filtered subset. That gives you scale without sacrificing final precision when it counts. Look at this balanced scale. It perfectly sums up the exact versus approximate percentile decision. On the left pan, exact. Green perfect tick for 100% accuracy, small data icon because it only works well on limited rows, and a tall high-cost bar showing the heavy CPU, memory, and time price you pay for sorting everything. On the right pan, approximate. 1% error badge showing tiny inaccuracy is acceptable, massive data icon for billions of rows, low-cost bar because memory stays tiny, and a lightning bolt for blazing speed even at planetary scale. The middle arrow says choose based on scale and precision needs. Tip the scale left when every decimal is critical. Compliance. Billing. Tip it right when you need fast, reliable P95 or P99 trends on huge telemetry, monitoring, alerting, dashboards. Most real-world observability lives on the right. Approximate wins for speed and scale without losing meaningful insight. Pick the right side for your use case, and your queries stay fast and useful. Why does this topic matter in interviews? Interviewers ask about scale-aware analytics choices. Common questions include when to use approximately _percentile versus percentile, and how do you handle P99 on large data? Understanding sketch-based approximation shows production thinking. This topic is key for observability, performance, and telemetry roles. Explaining hybrid patterns demonstrates pragmatic optimization. If you can say, I use approximate percentile for initial monitoring and exact on filtered subsets for alerting thresholds, you sound like someone who's shipped real systems at scale. To wrap up, exact percentile and ranking give perfect results but are expensive, sort-based and memory-heavy. Approximate percentile gives about 1% error, stays fast, and uses tiny memory, sketch-based magic. Use exact for compliance, billing, or small data. Approximate for monitoring, dashboards, and large-scale trends. Hybrid pattern. Approximate first to narrow down, then exact on filtered results for precision when needed. The philosophy is clear. At planetary scale, perfect precision is often the enemy of good enough speed. Choose wisely based on use case. That's episode 20 done. Thanks for spending time with me on ZoomInData. Next in episode 21, Binning and Discretization, we will explore the conceptual role of binning in time series analysis and histograms, and why it matters for grouping. Homework to lock this in. Explain to someone or out loud. Why use approximately _percentile instead of percentile? Think of AP99 latency query where approximate is acceptable. Answer this one. What is a good hybrid pattern for high-scale percentiles? If this helped, like the video, share it with anyone prepping for Azure interviews, subscribe for episode 21, and drop a comment with your biggest takeaway today. Thank you so much for watching ZoomInData. See you next time. Keep zooming in on those concepts. Bye for now.